All right, I have a question from solid state for you now. Let me read it out to you. A solid compound contains X, Y, and Z atoms in a cubic lattice. That's what is shown over here. This is the cubic lattice with X atoms occupying the corners. Okay, it's saying X goes somewhere. Y atoms are present at the body center positions, and Z atoms are present at alternate edge centers. I always have fun doing this kind of questions. It's asking what is the empirical formula of the compound. So I have drawn the lattice here. And this is the most important idea. Yeah, you just have to visualize this. Um, this question gives you easy marks if you're able to figure it out. If you're not able to visualize it, it becomes a little bit difficult. So yeah, if you practice enough of these kind of things, you should be able to solve any question based on these sort of ideas. So let me just quickly put these atoms on this. Yeah, we'll get started with this right away. So this is a basic FCC lattice that I've drawn here. Yeah, face-centered cubic. Yeah, these orange axis. This is basically showing that where they all intersect. This is the body center. Okay, and body center was what? Body center was which one? Which one? All right. I have Y atoms present at the body center. We use another color. What color do I use? It's two. Okay, let's do blue. Okay, so Y is right in the center. And these are face centers. Okay, the ends of this orange axis. And the corners are evident right away. So atoms occupy the corners. Okay, I'm going to use the same color there. Just write all the X's. Okay, I have 8 of these, right? This is fairly straightforward. Did I miss anything? Yeah, this one here. Okay. And the last one is Z atoms are present in alternate edge centers. Although we didn't really need these face centers, it's good to have this diagram in mind. Okay, so alternate edge centers. Where are edge centers? Okay, so these are there are a total of 12 edges, right? If I just mark them off over here, so I'm just going to put these blue lines to show that count the edges. So there are 4 over here, and then 4 horizontal ones on top, 4 vertical ones here, and then 4 more horizontal ones at the bottom. Okay, so I have these 12 edges totally. Now, out of these, alternate ones are occupied by Z atoms. So let me just put that here. If I put one Z here, then say there's nothing here. So I'm just going to make this out. Oh, no, that would be confusing because there's already an X there. Hold on. I'm not going to put anything there. So I'm going to put another Z here. Okay, so alternate ones of here are occupied. Same way here, I'm going to put maybe a Z here and skip this one. And, oh yeah, that's a good way to note it. I'll just put an O over there showing that this is empty. And alternate, I put a Z here. I remove this one. Same thing here. Yeah, just O's on these sides. And here I put Z. So yeah, that's it. That's I think more than half the battle won right there. Okay, figuring out what's done. Did I do this correctly? Let's just check. A solid compound contains X, Y, and Z atoms in a cubic lattice. Okay, X atoms occupying the corners. I've done that. All 8 corners by X. Yeah, you see that. Yeah, this is cool. And then Y atoms are present in the body center. This also is done. And Z are present at alternate edge centers. So it's important to read the question statement carefully, which is why I went through a lot of detail on just figuring this out. After this, you just need to know a little bit of theory on how much of these atoms, yeah, of these specific points on the lattice, what is their contribution to the whole? Okay, so for example, you know that corner atoms contribute to say 1/8 of the entire atom corner lattice points. The edge centers, well, since there are 4 of them, that would make up a whole. So let me just write edge here. This would they contribute say 1/4. And what else do we have? We just have a body center. Yeah. So body center is simply just the whole atom. Yeah, it's right in the center. It's not sharing it with anything else. How do I get these numbers? If you don't remember the theory, it is pretty straightforward. Imagine a room. Yeah, maybe the room you're in right now. You look at the corner of the room, you see that, okay, that's just one point there. It's a little bit difficult to imagine the corners. So go over the theory of that. Basically, there are 8 of them. Okay, if I were to just choose this here, if I were to do this quickly, if I were to extend this, something like this. Yeah, so there are basically 4 unit cells on this thing here. If I point, let me use a different color so that you can know what I'm talking about. If this guy here is 1, there's another one over here. This is 3 and this is 4. So 2 in the same plane and 2 in front of you. Okay. Similarly, there are 4 more above this. Okay. I know I'm doing a bit of theory, we were supposed to do quick numericals, but I think this is important. All right. So you have 4 in this sort of a bottom plane and then 4 more on top of it. Yeah. So I'm not writing it down, but basically there are 8 there. That's how you get this 1/8. Now edge, I get 1/4 because there are 4 things right here. Again, similarly, you have just 1, and in this case, that is 1 and 4. Yeah, these 2 numbers and 2 more on top. That's how you get 4. 2 and 3 don't count to this edge. Which edge am I talking about? This one right here. I talk about this edge being shared. It's shared between 1 and 4 and 2 more on top. So exactly half of the corner ones. And body center is pretty straightforward. I thought that this here is extremely important. After this, yeah, sure, you just go ahead and put these numbers and you get an answer. Yeah, this is fine. Now, X is present at the corners and one corner is shared by 8 unit cells. This is what I took time to explain. So number of atoms per unit cell is simply 1 by 8 times 8, which is 1. Y is present at the body center and it's used by only 1 unit cell. So there you go. There's just 1 there. So far I have, if I write it down here, X and I have Y, and Z is present at alternate edge centers. Okay, we did that very, very diligently. We did not, we were pretty careful about that, which means that instead of 12, now there would be 6 of these atoms, and then contribution is 1/4, and the number you get there is 3/2. So what you get is X, Y, Z 3/2. If you put it to a whole number, you get the answer to be X2, Y2, Z3. That's the answer right there. Yeah, so a recap, although it may not be entirely necessary because I spent a lot of time on this, but anyway, the main thing is to figure out the diagram, visualize this, which is why you need to know, read the question carefully. If you want, you could even draw this. Yeah, if you solve enough of this, you can pretty much put this in your mind map. Otherwise, sure, go ahead and draw it like I did, and you figure this out. You need to know what these contributions are. Yeah, this theory is important. You may not have time in an exam to actually do the kind of things that I did, but yeah, all in all, this is how you do a question like this.